Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Castle Elementary School, home of the Knights, and today we're all here to
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott, and we would love to have you join us on our program today. If you have a question and you live in Bakersfield and you'd like to ask us that question and it involves some math, give us a call. 636-4357 is the number here locally. Even if you're in San Luis Obispo, you can join our program. The number there is 866-636-6284. It's a toll-free number. If you want to email us your question, today would be a great day to do that. The email address is dothemath@kern.org. You can also watch the program, dothemathonline.net. And of course, if you have any kind of social media, you can find us there as well. We are located on Facebook, Instagram, Twitter, and YouTube.
All right, quiz time for you, young man.
Uh-oh.
If somebody calls in from San Luis Obispo County and we do their math problem, do you have any idea what they'll receive?
Ice cream.
From?
Doc Bernstein's.
There you go.
Yeah.
You passed the test. There you go. Nice. I was going to say, you've heard this enough times.
I've heard
now,
a couple
so
times.
You got it right there. So anyway, we do have phone tutors available on Tuesdays and Wednesdays until 5:30 in the afternoon. Programming note, next week is the final week
4 more shows
for live broadcast of Do the Math this season. So on Pi Day 3/14 will actually be the last day of live programming. Of course, Do the Math will be on reruns. I mean, we'll keep on throughout the rest of the school year and stuff. But this week and next week, the final 2 weeks for live broadcasting of Do the Math. As I said, we do have tutors in here until 5:30 this afternoon. We have a very special guest in studio. We also will be going out to Castle Elementary, visit with Devin and the students out there. But before we get to any of that, let's first take a look at today's Math in the News. All right. Today's Math in the News has to deal with, now I don't know if you've had to deal with this when your kids were younger or if you have to now or whatever, daycare someplace.
Okay.
All right, so like when you're at work and the kids have to get dropped off and then you go pick them up someplace. So have you ever had to deal with that? Or
we haven't had to deal with that, no. We have some very generous grandparents, which is nice.
Yeah, there you go. See, there you go. Benefit of having parents and relatives close by. Moving out here from New York, we had no relatives around, so. Anyway, so this is a thing that has to deal with kind of a daycare thing.
Okay.
All right. So a group, for 4 weeks, they monitored the pickup time of 10 different classrooms, recording how many parents arrived after 4 p.m. Before the 5th week, a notice went out to the parents of 6 of the 10 classes. So not everybody got it, but they're doing this little survey. Parents would be fined if the kid was picked up more than 10 minutes late. So you've got until 4 o'clock. If you show up more than 10 minutes late, you're going to be fined.
Okay.
All right. So it didn't reduce the number of latecomers, though. In fact, it increased. So here's the graph. Right. So here, let's take a look at the graph.
All right.
All right. So we can see the control group is the group in white. Okay. And here are the number of weeks that they did this. All right. So 20 weeks. And there were 10 people showing up late on the first week. All right, about 10. It looked like 8 or whatever.
Yeah.
Okay, and the control group stays pretty much what you would expect it to be.
Right around 9, 10. Something
now, the group that was getting fined is this black line. So you can see when they start getting fined, the number goes down.
Yeah.
Right? It goes almost in half, all right, after about a month.
Right.
But then, look at the spike.
What in the world? They say just to heck with it. We're just going to be late no matter what.
Right. You know, and then it dips a little, and then it's like, all right, so let me read the rest of it to you. So, behavioral economics professor offered an explanation. Before the fine was introduced, the teachers and parents had a social contract with social norms about being late. Thus, if the parents were late, as they occasionally were, they felt guilty about it. And their guilt compelled them to be more prompt in picking up the kids.
Okay.
Once the fine was imposed, the daycare center had inadvertently replaced the social norms with market norms.
Okay.
Basically, the fine removed the guilt and replaced it with a price tag. And in this case, they're saying the price tag was too low.
Oh, okay.
All right. So it was like, all right, we're going to fine you. And they're like, all right, you know what, that's not cool. I don't want to get fined. And then they're like, well, you know what? If all you're going to do is fine me a little bit of money, I'll come late all the time.
Right.
Right? So here you can see the number of late arrivals goes from close to 5 to 20.
Yeah, let me go ahead and pay my fine up front for this month.
Yeah.
Just count on me being late.
Here's a chunk of money. You know I'm going to be late every day. So what we're doing is they were looking at the average number.
Okay.
So I figured, all right, this article came out, and let's take a look at how that can be incorporated into some other math other than the behavioral, social norms and market norms and things like that.
Okay.
So mean, median, and mode.
Right.
So here we go. Let's take a look at these right now. This is something that a lot of students are working on in, I know, upper elementary schools and also junior highs, and they'll continue doing it forever. So anyway, mean is the average. You add up all of the numbers and divide it by the number of numbers. So if you have, let's say there's 8 numbers here, you would add them all up and divide by 8. And here's an example right here. The median is the number in the middle, but what you need to do is you need to put them in numerical order from least to greatest, then you find the number in the middle. And if you have 2 in the middle instead of just 1, you take the 2, add them up and divide it by 2, therefore you would get 6. And sometimes you can just logically reason yourself, like, all right, between 5 and 7, we know it's going to be 6. But sometimes the numbers aren't that nice to work with.
Yeah.
The mode, the one that comes up most often, and if there is not a number that comes up the most often, there would simply be no mode.
Right.
And that is today's Math in the News, and how we tied that in with the late arriving parents. And like, you want to find me, go ahead and find me double. As a matter of fact, I'll come even later all the time. But anyway, 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio right now, we have Kajal. How are you?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to McAuliffe Elementary and I'm in 5th grade.
5th grade, home of the Explorers, correct? How long have you been at McAuliffe?
This is my 4th year.
Your 4th year. Like it pretty good over there?
Yeah.
Yeah? Anything you would change?
Not really.
Not longer recess or longer lunch or anything, or that's cool?
Pretty long.
It's pretty long? Oh, good. So you're cool with being in the classroom. You like class? What's your favorite subject? Now, I know you're on a math program. You don't have to say math. If it is, cool, but if it's not, that's all right.
It is math.
It is math? You like doing math? Good. Well, you know what? Over to the board, young lady. We're not going to waste any more time. Go on over there. I'm going to give you a problem to work on.
Grab one of the pens.
All right.
There you go, and I'll get the other
one of your homework problems has to do with volume. Okay, and I'm going to modify this problem a little bit. Okay? So the volume is 120 cubic inches. So Scott can write that up there. 120 cubic inches is the volume. Okay? And this is just a rectangular box. Okay? Now, what they wanted to know from you is how many layers of 1-inch cubes there were, right? And you can see the first layer, and then you can see the dimensions there. I'm going to move this up a step on you, all right? I want you to give me the dimensions. What are the possible dimensions of a rectangular box that would have a volume of 120 cubic inches? So that's why you've got Scott right there, and your eyes get a little larger.
Her eyes got real big right there. Okay, let's see if we can draw us a box in 3 dimensions. So here's our box, and we know that the volume is 120 cubic inches. Tell me a little bit about volume. How do we find volume in the first place?
Do length times width times height.
Okay, so length times width times height. There you go. So there's 3 numbers. Where do those numbers usually go on a problem like this? Like, where would the length go? Where can I put an L?
Length would probably be
across. Okay, so we can put the L maybe going across like that. How about the width? How wide is something? Okay, so we can go W there. Good. And what about the height? Aha, all right, so there's 3 numbers that we need to have. So what do you do with all these numbers once you have them?
You multiply all of them together.
All right, and what's the answer supposed to be?
120.
So when we multiply our numbers, that you're going to magically make up in your head. They have to equal 120. Where are you going to start on a problem like this? What number are you going to start with?
120.
Yeah, but we got to work backwards and we got to find some numbers that are smaller, right? They're all going to multiply to be 120. Any ideas about what maybe the length would be in this problem?
Try 3?
Could be 3, sure. Let's do 3. So 3 times 2 more numbers would be 120. How much do we have left? Can you think backwards like that? If we've already used a 3 times something. Can you think about that in your head? 3 times what is 120? Interesting problem, huh?
3 times 40 is
Yeah, that's it. You got it. So 3 times 40 is 120. So by working backwards, you can probably figure out these two have to multiply to be 40, right? What are 2 numbers that multiply to be 40?
20 and 2.
20 and 2, exactly. That'll work well. 20 and 2. Here we go. We're going to multiply them all together. 3 times 20?
60.
60. And 60 times 2?
120.
120. Can you tell me about the measurements of each one of these numbers? What are they measured in? Meters?
Well, they're measured in inches.
They're measured in inches, that's it. So if we had to do this, right, we said that the length right here was 3 inches. The height in your example here is 2 inches, right? And the width over here would be 20 inches. There you go. Those numbers would certainly work. Now, are those the only numbers that we could possibly have? There's other ones? What else could we have? Give me another example of some numbers we could use that would still give us 120 cubic inches.
Here's a thing that I'd like you to do.
Okay.
I want you to get it so that all 3 numbers, and you could probably stay with the 3, are single digits.
Ooh, there we go. So if we stuck with the 3, we still have 2 more numbers to do, right? But we would like them all single digits. Now, what do these numbers have to multiply to be again?
Have to multiply to be 120.
All 3 of
All
them,
3
right?
of them.
But we have the 3, and then what's left? Remember that part up there? So what do these 2 numbers remaining have to multiply to be?
40.
Got 40, that's it. So what are 2 numbers that multiply to be 40 that only have a single digit?
8 and 5.
There we go, 8 and 5. That works great. 8 and 5. So those work. Are those the only numbers we could possibly have?
Probably not.
Probably not. There'd be a lot of other examples, huh? So we have lots of possibilities, but I think we at least found 2 of them where they're single digits. Could you have all 3 numbers? We have all 3 numbers single digits. Could you have all 3 numbers double digits?
I don't think so.
You know what? We're going to let her think about that one for a
That's a
moment.
good question,
Because what we're going to do right now is we're going to head out live to Castle Elementary and check in with Devin and the Knights.
Hey, thanks a lot, Mike. Back here at Castle Elementary School. We're in the after-school program with some of our fellow Knights. Say hi, everybody. Good afternoon. Hi. Wow. She literally said, hi, everybody. Good afternoon. That was phenomenal. I hope you guys picked that up. So today we're talking about data and graphing, and it's not usually a topic that we really get to a lot, but kids always enjoy the activity. So today, I wanted to collect some data on the kids here in our room, ranging from 4th to 6th grade. So I asked them to do what I'll ask you to do at home. And it's very unusual for me to do this on television, but I'm going to ask you at home to close your eyes. Don't change the channel, just close your eyes. And imagine the perfect pizza. It's all yours. You don't have to share it with anybody. No parents, no siblings, no friends. It's all yours, which means you don't have to compromise on toppings. Just the toppings that you like, whatever you want. It's all yours. Think about what those were. Okay, now you can open your eyes, because I would hate for you to watch the whole show with your eyes closed, because I feel like if I didn't say anything, some of you might do that. Power. So, we had our friends here at Castle do the exact same thing, and they wrote their perfect toppings for their perfect pizza down on Post-it notes. Now, they had a chance to share, and there are some really funny ones out there, really creative, and we'll share them with you in a little bit. But what I would like you guys to do now, very quickly, is count the number of toppings that you wrote down, okay? Once you have done that, what I want you to do is take your Post-it note, come on up to the front board, and put your Post-it note above the number that matches how many toppings you have on your perfect pizza. So come on up and put those up on the board. Now's the time. Come on up. right? We have a very interesting variety of preferences and pizza types. Wow. And remember, this is a pizzeria where there are no extra charges for extra prices or extra toppings, so the world is yours. All right. And I appreciate the fact, and let me just throw out there a thank you. What was your name, young lady? Alasia, right? Thank you for organizing some of those fives so that they were on top of each other instead of all around. That's actually going to come in pretty handy a little bit later on. Now, let's take a look. And we have some additional data still being created. That's fine. Do you have it? You ready to go? Go ahead and pop that up there. So let's take a look at the information that we have. So it looks like we have 3. So let's put this over here. Okay? Now, here's what I'd like to see if we can do. I want to see if we can create a line plot. Now, what a line plot does is allows us to take data that we've collected and organize it across the way here. So we're going to have to do 2 things. We're going to have to create a horizontal number line, which is what we've kind of already done here with our information. We're also going to want to create a vertical number line, marking off and representing the numbers, the amount of data that we've collected for each number of toppings. So I can figure we can go to 1, and then we can go 2, we can go 3, we can go 4. Do you think we need to go any higher with this data?
No.
Some people say yes, some people say no.
No.
Why do you say no?
Because there's not that much. There's only 4 and 5, and there's nothing hiding left.
Right, so we don't have to go too far beyond. Maybe we can do 5, and if we got more data and it grew taller and taller, then yeah, it would be helpful there for more. But I don't even think we need that. Okay, so I have some questions that I'd like to ask you about what we've just built. What does this tell us about the amounts of toppings that people like in this room? What do you notice just based on looking at what we've set up here? What story can you tell about that? Let's go right up here. Your name, sir?
Carlos,
Carlos, what do you notice based off of what you see?
most people chose 5 toppings.
That most people chose 5. So in data collection, this is called the mode. The mode represents the value that appears the most. Okay? What else do you notice about what you see? Yeah.
That there's 3 people that have 7 or 8 or 9
Okay.
toppings that they're their favorite.
Is there something else that's very similar to those data values that we see here? Yeah?
That 3 and 4 have each have 2 people who like the same toppings.
So usually when we see a graph that's on a line plot, we use X's or dots. I think this is actually an excellent opportunity to visualize this a little differently. We're going to draw rectangles around these entire sets. And then what do you see once we've done this, everybody? What kind of graph does this look like now?
Picture graph.
This looks, well, not so much a picture graph. We're not drawing pictures, but what are we drawing? This bar graphs, right. This is now, if you look, if we take all these away, we have a bar graph now.
Oh, it's like it goes higher, higher. and
Another
it'll
great
show-
way to visualize a lot of information in one place. Now, this is very familiar to a lot of people, but there's still more information that we can collect on this. And so when we come back, we're going to talk a little bit about another type of bar graph that tells us about spans of information called a histogram. But for now, we'll send it back to the studio. Mike, take it away.
All right, thanks for that, Devin. Hey, we do have phone tutors available until 5:30. We have Kajal in studio with us right now and working on the second part of this problem. Why don't you head back over to the board with Scott, and you did great on the first part of the problem. Now we've got the second part. So why don't you guys explain for those of the kids that are just tuning in what you're doing now?
Now we're trying to find out if we can find the volume except with doing all of these numbers as 2 digits.
2 digits, that's right. So here we go. I'm going to grab this pen. So we'd have some number times some number times some number. And the answer would still be
120.
120 cubic inches. Is it possible you think we could multiply 3 numbers together and all of them be double digits?
I'm not sure.
That'd be hard. What's the first one maybe you could pick? What's a good double digit number? I mean, you had a 20 there. That was nice.
10?
Yeah, 10. So maybe if we did 10. What could be the next number? What's the lowest possible double digit number?
10.
It is 10, yeah. So if we had the lowest numbers we could possibly do, what's 10 times 10 times 10?
That'd be 1,000?
1,000. So the lowest double digit numbers would give us way too much. I don't think it's going to work. However, I do like the fact that you picked 10 because we haven't used 10 yet. And maybe we could use 10, right? We used a 3, we used a 2, we used a 20, we used an 8, we used a 5, all kinds of fun stuff, but we haven't used a 10. What if we used a 10? What other numbers could we use to see if we can get 120 total? It's a good thinking problem, huh? Well, let's go back and see if we can use a strategy like we did last time, right? 10 times something equals 120. What's the part we're missing?
12.
12. Nice job, right? So this number is 12, which means these two numbers need to multiply to be 12 also, right? What are two numbers that can multiply to be 12?
3 and 4.
3 and 4. There you go. Are there other numbers that can multiply to be 12?
2 and 6.
2 and 6. So we could still have 10 out here. Times 2 times 6. Are there other numbers that can multiply to be 12?
1 and 12.
Hey, there you go. Don't forget about that 1. Sometimes we do forget about the 1 because it's just 1. But in this case, it would still be a shape like that. It would just be really skinny, right? But it would still be 1 high. That would be okay. Are there other ways to do it? Now, we started with a 3 over here. Then we started with the 10. Is there any other number we could possibly use? What about a bigger number than 10? What about a bigger number than 20? Can you think of a way to do it? Or we could multiply 3 numbers together and get 120, and the first number is bigger than 20. What could go there?
40 or 50.
Why don't you go ahead and put one of those in there? Oh, now we got a 50. All right, so what's next?
You had to do what to it?
What do you think?
Maybe... I don't know.
Well, we could try something. If you tried a 2, what's 50 times 2?
100.
100. And anything, can you multiply 100 times anything and get 120? That's not going to work, huh? So let's change this up just a little bit. I like your other guess that you had there.
40.
What if you put a 40 in there? Yeah, try that one. So 40 times what equals 120? 40 times what?
30.
40 times 30 would be 1,200. A little too many zeros. But you're good.
3.
No? There you go, 3. So this number's got to be 3. Now let's use what we used over here. Which two numbers need to multiply to be 3? See those blank spots?
3 and 1.
There you go. Put them in there. So that would work as well, right? Last question for you. Could you use a 0? Let's say we had this box and it was flat. It was totally flat, didn't have any height at all. Could you use a 0 here?
I guess you could.
Yeah, it seems like you probably could because it'd be a flat box, right? But think about what happens when you multiply numbers together and one of them is 0. What happens to the whole number when you multiply times 0?
It's going to equal 0.
It's going to equal 0. So we don't want that. We want it to equal 120. It has to, right? That was the thing we started with at the very beginning. Has to equal 120. So I'm going to ask you again. Do you think we could use a height of 0 in this problem?
No.
Not going to happen. No, never want a 0. We could use a really small fraction. We could use a really small decimal, but we couldn't use a 0. We could not have a flat box. Nice job on that problem. That was fun.
All right, don't erase it because you thought you had the last problem.
Uh-oh.
So,
We got more.
what I'd like you to do is, where you had the 10 and the 40 and that kind of stuff, you get rid of that stuff. Leave the 3 by 8 by 5.
Okay.
So maybe get rid of all of that other stuff.
Got rid of that part. Nice job. Hey.
So I've got a little challenge for you here.
Right.
So the 3 by 8 by 5 was pretty close to having a cube.
Right.
Okay, so what I'd like you to do is see if you could figure out the measurements so that you get very, very, very close to a cube. Okay, and here I'm going to give you a hint. One of the numbers, okay, so if it's a cube, what does that mean? What has to be the same?
That's a good question.
All of the sides.
All of the sides have to be the same, right? Okay. You're not going to get 3 numbers that multiply to get 120. but you're going to get two numbers the same and one different that are going to get 120. One of the numbers, I'm going to give you a hint, will be a decimal.
Oh, interesting.
So if you know the other two numbers that are the same, and you know the eventual outcome, you can figure out what the decimal is. So go ahead and tackle that problem, and I'll give you guys 5 minutes to work on that.
Wow, we got some time to do this. Okay, so we want to make sure that the numbers are as close as possible. The numbers that we used in the first part, were they very close? 3 and 20 and 2?
3 and 2 are close.
3 and 2 are close, but 20 was pretty far out there, huh? So the ones that we used that were the closest were 3 and 5 and 8, right? Where do you want to go with this problem? You want to use any one of those numbers?
Not sure.
Which one do you want to use?
Maybe the 5.
Maybe the 5. Okay, so let's do this. We're going to do a little experiment here.
Before you guys go, why 5?
That's a good question.
Well, doesn't 5 go into 120?
Oh.
5 does go into 120, so that's a very good place to start. So
like
continue.
That. Okay. So if you had 5 in the first one, right? He said that 2 of them were going to be exactly the same. Do you think it's the 5 that's going to be the same?
5 times 5 is 25.
Yeah, that's true. 25 times what is 120?
And this has to be a decimal.
It would have to be a decimal. How in the world could we figure out that decimal?
We could divide.
We could divide. Can you show us how to do that over there? You have a pen in your hand. I want to see what you're going to do with this division part.
We can do 120 and divide it by 25.
Oh, okay. I gotcha. Now, why did you choose divide? Because everything we've been doing so far is multiplication.
Well, we need to find something. 25 times y equals 125, so you do the opposite.
Do the opposite. I like that. All right, you're on the right track. Let's see what we got here. Do 120 divided by 25. And you told us it was going to be a decimal, right? So you're probably going to want a decimal in that problem, too. It's tough, huh? But you can do it. Here's the decimal. We'll even add another 0 out there. See what you can do.
That equals 0.
Yeah, that's true.
It's multiplication.
So 25 times 4.
That equals 100.
It does. That's pretty close, right?
Yeah.
Do you want to use 4?
Yeah, because
Okay.
it can't go any bigger.
Can't go any bigger. Yeah, that's true. You're going to bring down that to 0. Good idea. Okay, so now if 25 goes into 100 4 times, 25 goes into 200
8 times.
8 times. How'd you come up with that?
Because if 25 times 4 is 100,
Yeah, there's 4.
25 times 8 would be 200.
That's right. There you go. Another 4 for 200, right? There you go. So try that 8. Put that 8 in there. No remainder? So that worked out pretty well. What number do you get?
4.8.
Well, that's not very close to 5, is it?
Well, it is.
It is. Look at that. It is awful close to 5. 4.8. So I'm wondering if we have solved this puzzle to be awfully close to a cube, because we have 5, and we have 5, and we have 4.8, which isn't quite 5, but it's very, very
Real
close.
close.
Yeah, exactly. I think we made a heck of an effort on that one, Mike.
There you go. Nicely done, Kajal. I like the reasoning on that also. And you know what? Did a nice job on that. We're going to send you to our friends at Chick-fil-A, so congratulations on that. 636-4357 is the phone number. We do have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Sunset Middle School, home of the Rockets, and today we're here to
Do the math! Yay!
Well, today we're at Sunset Middle School, and I've got 6th grade student Eduardo with me. How are you today?
Good.
You ready?
Yeah.
All right, let's go. We're going to work with some exponents today. So, if I have 2 to the 3rd, which one of these numbers is the exponent?
The exponent is the 3.
The 3. And you know what this other number is called besides 2? What?
It's the
And I know I'm throwing you on the spot there, but the base number.
Yeah.
All right. So 2 to the third, all right. Is there another way to write that?
2 plus 2 plus 2 plus 3 times.
Right. So is it plus or times?
No, 2 times.
There you go. So why don't you go ahead and write it the other way that we can represent 2
times 2 times 2.
Okay. So 2 to the third, because some students might look at that real quick and think, oh, 2 times 3 is 6. But is that what this is?
No.
What is it?
It's 2 times 2 times 2.
Which would equal what?
Which would equal 8.
And how did you get that?
Because I first did 2 times 2, and that would equal 4. Then I times it by 2, and that would equal 8.
All right, so let's do something different. Let's take the exponent, make that the base, and make the base now the exponent. So how would we read that number?
It would be 3 to the power of 2.
Perfect. Well, you could say 3 squared. There are a lot of different ways to say it. So how would we rewrite that? Because is this 6 now?
No.
No. That looks like we could get 6. This looks like we could get 6, but it's not even going to equal 6, is it?
No.
So rewrite it and tell us what we're going to come up with here.
So it would be 3 times 3, and it would equal 9.
All right. So we had the 2 and the 3, 3 and the 2. We rearranged them, and we got different numbers. All right? So let's try this. Let's try 2 to the 4th and 4 to the 2nd. So why don't you try those?
First, I'm going to do those.
Perfect.
Which would be 4. And then do these would be 4. 4 times 4 is 16.
There you go.
And then I have to do 2 4s because the power is 2.
Nice.
And then that would equal 16.
Well, that's pretty weird, huh? This time we took the same 2 numbers, reversed them, and we got the same answer. But up here we didn't, did we?
No.
So nice work with exponents, nice use of the vocabulary, different powers and how they can be rewritten and things like that. So Eduardo, nice job, dude.
We are opening the exhibit for the California condor at the California Living Museum. The condor is one of the world's rarest birds. It's also the largest bird in North America. Condor 324 is unfortunately in captivity because it has some behavioral issues. Habituated to people, fed by a group of hunters, and because of that, it's no longer able to remain in the wild.
We have 25,000 kids that come here on field trips every year, and the fact that they'll be able to see these birds in real life as opposed to a textbook, it just helps that learning, and it helps them be more aware of their environment.
For kids to actually see them, for them to see the kinds of things we need to do to make sure that these animals survive, it's just something that makes us feel that education is more than paper and pencil. It's about experience.
It's really amazing, especially a home like Calm. You know, we're right in the middle of condor habitat. The mountains behind us are part of the habitat for the wild flock that I manage. And so to have this condor help teach people about the threats that condors face, it's really an honor.
And just a reminder, we do have phone tutors available until 5:30 this afternoon. And we have Kajal in studio, and we'll be back with more right after this. We're going to head back out once again to Castle Elementary and check in with Devin.
Hey, thanks a lot, Mike. Back here at Castle Elementary School, just an update on our population here. We've had a lot of walkers go on home, and we want to let you know who's remained. I feel like this is a reality game show to see who the last one standing will be. No, but we're just all here. It's the after-school program. We chill until they say we can't. That's what we do here. It occurs to me during our last segment that I forgot to put down my perfect pizza toppings, and I'm a very boring guy. I only have 2. Ricotta cheese and, not goat cheese, ricotta. I'm Italian. I say it like that. ricotta cheese, and spinach, which means there's a really good chance that if you eat a pizza with me, I'm going to have something in my teeth. So I'm going to go ahead and put that there. And there were some changes to our data since we last left our break. We analyzed some of the numbers and recognized that, some of these that we put under 5 should actually be under 6. Some of these that were under 5 should actually go under 4. So it looks a little different than when we last left you. And what it's done is it's created a wider spread of data. And what's really interesting is that we don't really have any outliers. There's no data that is so far out of the realm that it skews the rest. So it's pretty well centered. But it's really difficult to tell too much of a story about generalizations. Like we can say that, yeah, 4 has the most, but is it really by all that much? No. So what we want to do is collect the data in a bit of a more condensed range. And so instead of using individual data points, we're going to use ranges of data and then reorganize our information in what is called a histogram. So this histogram, and I'll even make sure we title this if you haven't seen this term before. A histogram is a type of bar graph that uses ranges instead of individual data points. So in order to be able to do that, we need to be able to identify our ranges. Now, some really important things with a histogram, all the ranges should be of the same size. So we couldn't just do 0 through 1 and then 2 through 12 because that range is too big. We want all the data ranges to be the same size. So what do you think would be a good size for the range? Should we go 3? Should we do 2? What do you think?
0 through 3.
You want to do 0 through 3. Are there any other ideas we want to try? Yeah?
0 through 10.
0 through 10. Now, what do you think would look like? That would be all the data, right?
3 to 9.
Now, 3 to 9 would be a big range, and all the other ranges would have to be the same size. I don't think we could be able to pull that off unless we start here. What do you think?
0 to 6.
0 through 6, but then what would happen to the other range? That would be very big. We want to be able to spread the ranges amongst the data evenly. I think 0 through 2 would be a good start. So what I'm going to do is I'm going to go ahead and relabel as 0 through 2. That means all of the data from 0 through 2 is going to be built up into its own bar. So this whole range represents all of the pizza toppings that are between nothing and 2 toppings. Now, if all of the ranges have to be the same size, what is the next range going to be? Yes?
3 through 5.
3 through 5. So what we have to do now is build our range using all of this data. Now, I think you're going to notice something here that really stands out. We're growing this, and we're growing. Oh, bless you. That was one of the biggest sneezes of the year on camera, ladies and gentlemen. That might be a do the math decibel record. Wow. This definitely changes the way we see this data that was in the middle here. So, we got our, yeah, I think we're starting to see something here. So, now, this bar, way up, in fact, so tall that we need to add some pieces to our axis here. What's our next range going to be? Shout it.
6 through 8.
6 through 8. So let's reorganize our data on 6 through 8.
I thought you were supposed to
Yeah.
erase the 6. I have a question.
So we're going to keep the 6, and we're just going 6 through 8. What was your question? I heard? Yes.
So once we do that for that, from 6 through 8, so it would be, next one would be 9
Yeah.
through 10, but
9.
then there's no 10.
Well, it wouldn't be 10, and you're right, because there is no data beyond 9, but we still want to keep the range. So what would that range be?
So it's just
So it'd just be 1?
Well, how wide is the range on each of the intervals we've done so far? So it's 3, right? So we have to include 3 starting at that 9. So what would our range be?
11.
9 through 11. Okay? And yeah, there's only one piece of data here with this range. So, now that we've created this histogram, what can you generally tell me about the number of toppings that people like on their pizza? Yeah.
pepperoni.
Well, what about the number? Talk about the number. Yeah.
most likely it would be for 3 to 5. It would be 7 people who would like toppings at 3 to 5.
The story we were able to tell with this data stands out much more clearly with a histogram when you work out the ranges. Because like she said, now the story is most of the people that told us what they like chose anywhere from 3 to 5 different toppings. When we come back, we've got one more data visualization for you. We're going to look at the box and whisker plot. But for now, we'll send it back to the studio. Mike, take it away.
Thanks for that. The good old days of Box and Whisker. You remember that? Yeah, nicely done. The stats over there at Castle Elementary. All right, we have Kajal in studio, and she has been doing some great work with volume, but it's time to mix it up a little bit. You ready? All right, so we're going to do a little always, never, sometimes game. So you're going to have to decide if the problem is always true, never true, or sometimes true. And if it's sometimes true, you have to explain when it would be true. All right? Okay. So why don't you head on over to the board with Scott, and we'll go ahead and we'll do this first one. So we have 12, and then there's a symbol.
Which pen do you want?
I don't care.
Good choice.
All right, so we have 12, some symbol, and then x plus 6. So Kajal, I'd like you to explain what that symbol is, what does it mean, and then how do you solve the problem?
Symbol is the greater than symbol, which means whichever way it's facing, the number would be greater.
Now tell me about the facing, because one has a little pointy end and one has a big end, right? So which one's bigger, the pointy end or the big end?
The big end.
Oh, okay, gotcha. So it's saying that 12 is bigger than what? Bigger than what? What's the x plus 6? Tell me about that.
X plus 6. The x is a variable, so you have to find out what plus 6 would be less than 12.
Gotcha. Okay, so if you had this problem and you weren't too worried about always, sometimes, or never, what would you do with it? How would you go about solving this problem? Figuring out which numbers could go in there for x.
Well, I'd add numbers that would probably be something less than 12.
Okay. So what could x be?
X could be 5.
If x was 5, right, would this be true?
Yes.
Hey, good deal. Because 5 plus 6 is 11, and 12 is bigger than 11. Mm-hmm. What's another number you could possibly have?
4.
4, okay. If x was 4, would this be true? Mm-hmm. Why?
Because 4 plus 6 equals 10, and 10 is less than 12.
Good. If x was 15, would this be true?
No.
No? How come?
Because 15 plus 6 would be 21, and 21 is greater than 12, and the number is supposed to be less.
It's supposed to be less than 12. All right. So what if x was 6? I like 6 because we had 4, 5, and 6. If x was 6, is this true?
No.
What? Oh, come on. It makes 12.
Exactly, because the sign says that it's supposed to be less than 12.
Oh, gotcha. Okay. So this doesn't work either. So some things are true, some things are false. What about a decimal or a fraction? What if we had, I'm going to stick this right in the middle here, x equals 4.5. If x was 4.5, would this be true?
Yeah.
It would? What would you get if it was 4.5?
10.5.
Okay, so that would be true. So tell me, is this expression always true for any number in the world?
No.
No. So we can eliminate always. Always is not going to work, right?
Mm-hmm.
Is this expression never true? No matter what number you put in, it never works?
No.
No, we can eliminate that one. So never is not going to work. There's only one option left. Do you remember what the other option was?
Sometimes.
Sometimes. So sometimes this is true, depending on what word, or sorry, depending on what number you fill in for the x, right? Can you give me a general rule? What should the number be? How do we determine whether a number is going to work or whether it's not?
The number should always be less than 6 because 6 plus 6 is 12. 12 is equivalent. So it always has to be less than 6.
So you're telling me x is less than 6 like that, right? Is there a way you can get from here to there mathematically?
You can do 12 divided by 2.
You could, right? But then you'd have to divide the 6 by 2. That wouldn't work out very well. What if you did the opposite like you did in that last problem? You told me we could do the opposite, right? So if you did minus 6 over here, you do that too. I like this. This is kind of a general idea. So if you want to have a little test for this one, and I say, will negative 20 work? You can plug it into the test. Is 6 bigger than negative 20?
Yes.
It is, so it'll work, right? We don't even have to plug it in there to see if it'll work. We have a little test that we can use there. So sometimes it's true, sometimes it's not. Nice job on that one. I like it.
There you go. Well done. Let's take a look at the next problem.
All right.
And this one says, so you can erase that, and we have 50 is 23% of 46. And once you get an idea of percents and things, you'll be able to see how this could be worked out rather quickly.
Okay.
But let's see how you want to approach this.
She says, hooray. Percentages are my favorite, right? Is that what you're thinking? Yeah, kind of. What do you want to do with this problem? How are we going to go about solving this one?
Not sure.
Well, don't worry about the always, sometimes, never. We'll do that later on. If you just had this problem as a regular old problem, how would you go about solving this?
Maybe try multiplying or dividing somewhere.
Give it a shot. I'm going to get our always, sometimes, never ready to go over here. But you have a pen, so why don't you do some work over there and see if we can, she says, what are we going to do with this thing? Maybe we could multiply, maybe we could divide, maybe we could, Well, one method you could use, you could take this percent and change it to a decimal, okay? And in math, of means multiply. So I'm going to go ahead and go along with what you were saying. Can you multiply those two numbers together and see if you get 50? You're looking at it awfully skeptically.
It's supposed to be 4.
That is supposed to be 4, you're right.
Okay. You're right, too small.
Okay, so we got 0.23, go ahead. Times 46, good. 18, carry the 1, and we got 13, good. 12, and 9, so far so good.
It doesn't equal 50.
It doesn't equal it. Well,
Wait.
Oh, wait. Oh, we got 2 spots.
Doesn't equal 50.
Still doesn't equal. Okay, so this answer would be 10.58, and that doesn't equal 50. So, is this always true?
No.
No, we can eliminate that one, right? Now we have a more interesting question when we say, is it sometimes true or never true, right? We're not quite sure. Maybe there's another scenario where it is. Maybe we could do 5 or 6 problems and figure out that it's never true. Can you look at these numbers here and see if you see any relationship at all between the numbers? Is there anything that looks kind of like they might go together?
If you moved the decimal and made it a whole number, 23 times 2 would equal 46.
Ah, okay. So what if we just took this problem right here and we took that part out, right? So we have these numbers, 50 and 23 and 46. I like what you're thinking. Tell me that one more time. If you took the 23 and did what?
Multiplied it by 2.
Multiplied it times 2.
It equal 46.
Equal 46. So tell me how the 2 factors in there. Is there anything we can do with the 2 and a 50?
Maybe we can see what happens if we multiply all of them by 2.
You could multiply a whole bunch of them, right? But we still have to have, I like the fact that you're thinking about multiplying. We have to have a multiply in there somewhere, and we also have to have an equal in there somewhere, right? Because the is an equal. Very interesting. Think about your percent, right? We did some percent here. Think about the percent of something, right? You said if you did 23 times 2, you get 46. What if you went the other way? How do you go from 46 to 23?
You divide 46 by 2.
Divided by 2, right? Is there another way you could say that?
46 over 23.
46 over 2 would give you 23, right? Is there any other way you could say that? Think about this. Cut it in half. Would you say that 23 is half of 46?
Yes.
All right, can you tell me a little bit about half? Tell me how we could express half in a different way, maybe even using a percent.
Well, we can make it as decimal, as in 1.2, so it'd be 2%.
Okay, think about this. 1/2. What would 1/2 be in a decimal?
Wait, sorry, 0.5.
Yeah, 0.5, that's right. So if it was 0.5, oops, that's supposed to be a 5. How would you make that into a percent?
I just know it equals 5.
It does equal 0.5, right? But we would like it to be a percent. So think about this. Percent has the word cents in it, right? The cent, like money.
5
If we
cents.
have a dollar, what's half of a dollar?
50 cents.
50 cents. So half is the same as 50%. Isn't that convenient? Look what we have here, right? We have a 50. So you tell me now, where does the percent go, where does the times go, and where does the equal go? Go ahead. We have 50, 23, and 46. How can we make this work? Well, where does the percent go in our problem?
50.
That's right. Can you put the percent next to the 50, please? So we know that part, right? And so if we were going to write this, 50%
Equals.
of what? 50% of the big number. Which one's the big one?
46.
46. Can you write that one down? Is.
Is. Let me write that.
Yeah. Is or equals, either way. Is what?
22.
That's right. So we still use the same numbers, but we moved them around a little bit. We changed it to percent, so they do relate to each other. So is it the case that this is never true?
No.
No, we made it true, didn't we? We fixed it. So we might be breaking the rule just a little bit, but we have justified our answer. Is this sometimes true? Yeah. If you move the numbers around enough, you can make it work, right? I like the way you thought through that problem. Nice job.
All right, nicely done. Well, you know what? We've got one more to do, so go ahead and erase the board.
Okay.
And here we go. We have 4x plus 2
I already figured this one out.
is equal to 3x. And I will give you 100 seconds.
Uh-oh.
Go.
You got to go. She said she
Do
figured it
these
out,
two
so here we
numbers
go.
have to be the same?
Show me.
Do they have to be the same?
No.
What's it gonna write? Oh, wait.
Wow. Oh, I see what you're doing. So when you have an x and an x, yes, they do have to be the same.
Oh.
I misunderstood your question. Try again. What number can you plug in there? You think you can make it true? We have these choices. You're feeling awfully confident, like we can make sure it happens, huh? So we're going to say it's not going to be never true. Sometimes or always. Let's try a 1. If you put a 1 in here, would it work?
It'd be 4.
4 plus 2 is 6. Is 6 the same as 3 times 1?
No.
No, so that won't work. X equals 1 will not work, right? That's false. What if we have x equals 2?
4 times 2 is 8 plus 10. You can't multiply anything.
That doesn't work. That's kind of weird. Also, huh? Anything else you could possibly use?
Maybe 3. Maybe.
What if x equals -1? -4 plus 2, what's that?
-2.
Yeah. 3 times -1? -3, we're awful close. That doesn't work either.
Half a minute left.
Try one more. Try that one, see what happens.
3, 4.
What's 4 times -2?
Negative.
8, good. Plus 2.
-6.
Good, this is -6. What's 3 times -2?
3 -6.
Hey, look at that, we made it work. So it is possible. No, no, no.
Yes.
Yes.
There you
So I
go.
think that we are headed towards the sometime.
Nicely done right there.
Nice work.
Hey, you know what? We have one more opportunity. We're going to head out live to Castle Elementary, home of the Knights. Check in with Devin.
Hey, thanks a lot, Mike. Back here at Castle Elementary School with our fellow Knights. And we've been talking about the perfect pizza toppings. And everybody that was in here has had a certain number. And we've talked a little bit about where the most people had their number of toppings that was ideal for them. No matter what toppings they chose, what was the perfect number that most people went with? And in our last break, we used a histogram to talk about the cluster of values. And I wanted to share another visual that, especially in 6th grade, gets some attention, but not the attention that it deserves, unfortunately. It's called a Boxwhisker Plot. And what that's going to do is let us see all of the data in one clear-cut line. Now, I had a very big question that I asked our students here. What we did was we took all of the numbers of our Post-it notes and put the number that each represented of toppings on the perfect pizza in order. And then I asked a very simple question, which was way more in-depth than I was prepared for them to hear. And the question was, of these values, which would you say is in the middle? And it sounds like a very straightforward question, but this conversation legitimately went for at least 5 minutes, with people running up and pointing at each other, and I think somebody got bitten. I can't confirm that. But we had some answers come up. What would you say was the number that you said was in the middle?
I say it was 2.
You said 2 was in the middle. So go ahead and explain why you went with 2 as the number you thought was in the middle.
I did it because then if there was another one for 14, it would be 2, because then it'll skip to 14. And then if you count from 0 all the way to 2 and then go 3 more times, all the way to the end, there would be 2 left.
So you're looking at, okay. So when we talk about data visualization, you can see that the word middle is often it can have a lot of meanings. And so I think it's important to introduce a term to clarify what exactly it is we're looking for, and that's the median. The median is the number of the value who's located in the center of all the other values when placed in order like this. So instead of thinking about what's in the middle, which of these values would you say is in the center? What would you think? There's a lot of thinking going on. What would you say is in the center? What do you think?
Okay, so I might not be wrong. I mean, right. But I'm thinking it's 3.
Okay. How would you say 3 would be in the center?
Because like 0, 1, 2, 6, 8, and 9, they only have one number between each.
Okay, so actually what you're doing is really insightful. Okay, we take 3 off of each side, and now we're left with what's in the middle. Is there something else we can take off of each side?
Well, because 4, 4, 4, and 5, 5, 5, like, they have 3 of them and 2.
So, I see what you're doing. So you're looking at the sets of numbers, okay? Let's actually take the values themselves. We got 3 off of each end. Could we take another 3 off of each end? Just to get closer to the middle here?
Yeah.
Now we have these 2. We have 4 and 4. What number is between 4 and 4? Well, it's both 4, right? So that's 4. 4 is our median. So now, in creating a box and whisker plot, we're going to go ahead and draw that line, okay? We're going to use green just for the sake of color. That's our median. Now, I have a couple of other questions here. We've split this data in half, okay? On this side, what would be the center value? Well, we take the same amount off the beginning and the end, right? So let's get rid of 2. Let's get rid of 2. Let's get rid of 1, 1. And it looks like 3 is in the center there, right?
Yeah.
So that's what we call our first quartile. What about the second half of the data? What would be in the center? Well, let's get rid of 5. Yeah, because we get rid of 3 on one side, 3 on the side, and here's our 5 in the middle. That's called our third quartile. Now, what is the lowest value in our data? 0. I'm going to go ahead and put a little dot at 0 and draw it to our first quartile. What's our largest value data?
9.
So let's put a dot. They said 9. So let's put a dot at 9 and then connect it. What we've done is created a box and whisker plot, like on a cat, whisker. Cute. But what this does is it shows us where most of the data is and then where the extremes are. So we can tell just by looking at this that most of our numbers are between 3 and 5, kind of like what we saw on our histogram. So that shows us measures of variability. So right now we're going to send it back to the studio. Hey guys, thank you so much for helping us out today. Back to the studio, Mike. Have a wonderful afternoon, everybody. Take it away.
All right, thanks for that, Devin, and all of the students at Kajal Elementary. Remember, we have phone tutors available until 5:30. Big thanks to Kajal coming in this afternoon from McAuliffe Elementary and doing some great math. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California. Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Susie. And you can call us with your math questions today at 636-4357. If you're in San Luis Obispo or other areas, you can call toll-free at 1-866-636-6284. You can also email us at dothemath@kern.org. You can also watch online at dothemathonline.net. And we are also on social media, Facebook, Instagram, Twitter, and YouTube.
All right, quick programming note, because today is the 13th and tomorrow is Pi Day, 3/14.
Right.
Today are the final 2 days of live broadcast for Do the Math for this season. So if you do have questions, you need to get them in today or tomorrow, the final 2 days of live broadcasting for this season. In a little while, we'll be going out to Actus Junior High, visit April and some students out there doing some work. We have a very special guest in studio. But before we get to any of that, let's first take a look at today's Math in the News. And this literally ripped right off the front page of Saturday's newspaper. So here it is, the front page of the Bakersfield Caledonian on Saturday. Working the problem. Students put their math skills to the test during annual competition. These are students and they're from Kern Middle School, and this is part of the 300 students that took place in a math competition with the Bakersfield City School District, and it was the 32nd annual Math Bowl. And are you familiar with this?
Oh yeah, I've been.
Okay. And one of the Do the Math tutors, Hilda, works with Do the Math, was kind of one of the people putting this on and helped coordinate it and things like that, and says this is something that motivates them, and one of the other quotes is, we're trying to make it fun because math should be fun. And indeed, it shouldn't be, you know, like, oh, I don't want to do my math today or something like that, because that way students can see how it relates to everyday things that go on in the world every day. So I figured let's go ahead and take a look at some of the problems down here. And it was, are you smarter than a 6th grader? All right, so let's go ahead and we'll just take a look at some of these right here. If the pattern below continues, what letter would appear in the 400th position? So it says math is the greatest, math is the, and then it just keeps on going. Another one is, what's my number? And then you've got some clues. The number can be divided into 240 evenly, divisible by 12, greater than 25, and less than 50. So with all of those clues, you can come down with what the final number is. And then you've got another one where you've got an item, and then you've got it on sale with a discount taken off and things like that. But this is what drew me to finally use this one for today, because here are the answers. And right there it says, do the math.
Of course.
So it's like, oh, do the math, and then that way you can figure it out. That's right, hooray indeed. So you can see some of the answers right there, and the one with the, can you figure out the number? Well, you can see that with all of the different clues, it comes out to be 48. And then they have a substantial explanation of the final one, where you're doing the percent, taking it off, and things like that. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays. However, as I just mentioned, today and tomorrow, the final 2 days of live broadcasting for Do the Math this season. In studio, we have Audrey, and how are you today?
Good.
Why don't you let everybody know where you go to school and what grade you're in?
I go to Bill L. Williams, and I am in 6th grade.
Now, how long have you been at Bill L. Williams?
Since I was in kindergarten.
So you've been there 7 years now. So you are a pioneer at heart through and through, correct?
Yes.
All right. Now, there are a lot of times I ask, all right, what's the best thing about Williams? What are you going to miss? Things like that. So you're getting ready for junior high next year. Have you gone to your orientation yet?
No.
So you're going to be doing that pretty soon, right?
Yeah.
Do you have any idea when that is?
It's on Thursday.
Oh, this coming Thursday?
Yeah.
Oh, so it's right around the corner. So what's one thing you anticipate, or one thing you're looking forward to, or one thing you think you're going to find out about junior high when you go to the orientation?
I want to know what each classrooms are, and I want to see where the orchestra room is and meet the orchestra teacher.
Okay, so you're in orchestra now, or is that something you're going to start?
I'm in orchestra.
You're in now? What do you play?
The violin.
Yeah? You're pretty good? Yeah, there you go. Why not? Yeah, you're pretty good. You're pretty good, right? Well, you know what? We've got a couple of minutes. Why don't you head on over to the board, and we're going to take a look at some of the things that you're working on in class right now, okay? All right, head on over there with Susie. And this is a problem that I am quite confident you'll be able to solve. All right? So let's go with, let's turn the page so we get some other distributed property in here. All right, 5. So go ahead and start the problem all the way over on the left. There you go. So 5, open parentheses. Yep. 1 plus 5n, close parentheses, minus 3n equals 115. Or 115, yeah. So you can just erase that 0. 115. And if you would be so kind as to solve for n and explain to Susie what you're doing, and if you get stuck somewhere, Susie's right there.
What are you going to do first?
Multiply 5, 1.
I agree.
And 5 times 5.
You're going good.
Minus
I think you're bringing down the negative 3n.
Equals 115.
How do we move it down again to give her some more room?
Oh, you can just slide it on the side. You see the bar?
Oh, yeah. Oh.
Whoop. There you go.
There we go. Okay. Let me guess. Are you going to combine like terms?
Yeah.
Oh, okay. Read your mind.
The 25n and the 3n?
Right. So she still has the 5. Mm-hmm.
22n?
Mm-hmm. I agree.
Equals 115.
Okay, let's give you some more room.
And then you subtract the 5 from both sides.
I would agree.
Oh.
That's okay. We know it's a 5.
Minus 5.
Yep.
I don't need the positive sign, do I?
No, it's okay. It wouldn't hurt. Okay.
22n equals 110.
Mm-hmm. We're almost out of room. We might have to go over to the side.
There you go. Yeah, you can just go over to the side if you need to.
So what are you going to do next? I can tell that you know.
Divide 22 into 110?
Yep.
Oh.
Sometimes you can kind of estimate. 22 is close to 20, and 110 is kind of close to 100. So you can get a good start by thinking how many 20s go into 100.
5.
Okay, so try that. If it's not 5, it'd probably be 4 or 6, but 5 sounds good to me. You can also check it this way. You can just do 5 times 22 and see what you get. Because that's what you were going to go around and do anyways, right?
Yeah.
It works, doesn't it?
Yeah.
Okay, so if we divide both sides by 22, okay, so you already did that.
Yeah.
Do you know why we only have n left here?
Because n is a variable.
Right, and then what's 22 over 22?
Just n.
Just 1, and 1 times n is n. Okay, very good. I think she knows what she's doing.
There you go. N equals 5. Nicely done on that first one, Audrey. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to go out and about, visit with April at Actus Junior High.
Hello. We're here at Actus Junior High, home of the Americans, and I am here with Mina. Mina, what grade are you in?
I'm in 7th grade.
7th grade. And what do you like here about Actus?
I like the PE sports and games that they play.
Very nice. And what's your favorite subject here at Actus?
Math.
We are in the right place here. Okay, so we have a problem today. Do you know what we're working with?
Inequalities.
So today we're going to work with inequalities. Here we have, go ahead and pick up this pen. 4m is, what does that say? Do you know?
Greater than or less than.
Greater than or equal to?
Negative 4.
Negative 4. So we're working out 4m is greater than or equal to negative 4. And how many solutions are we going to have here?
Infinite answer.
Okay, so we're going to have an infinite amount of solutions. If I'm looking at this problem, what am I looking for?
You're trying to figure out the value of m.
The values, because there's infinite, right? There's more than one. So we're trying to find all the values of m. So I have 4 times m is greater than or equal to negative 4. So what should I do in order to find that value of m?
You're supposed to divide 4 by negative 4.
So let's see you do that. So why are we dividing 4 by negative 4? Or positive 4, right?
Yes, positive 4.
Okay, so why are we dividing 4 by 4?
Because in order to get the answer, then you need to do, what is it, inverse operations?
So inverse. So this is 4 times m, so we need the inverse operation, so we're going to divide by 4 on both sides of the inequality. And what do we know about m?
M can be any answer. It can be an infinite amount of answers that we don't know yet.
Okay, so m is going to be greater than negative 4 divided by positive 4 is negative 1. Perfect. Okay, so since I have an infinite number of answers and it's not just not one single answer, how can we show that? What's the best way to show that?
With a graph.
Okay, so we're going to graph on a number line. We're going to start with 0, very nice. And then we're going to put, is it okay if we don't put other numbers on there? Okay, that's fine. Let's cap that, because when we show the answers, let's show in a different color so we can be visible here. So where are we going to start on our number line?
We're going to start at negative 1.
So do I put an open circle or a closed circle, and why would I do whatever we're going to choose?
You put a closed circle to show that it can be either negative 1 or anything greater than negative 1.
Because here, where it says equal to, it includes negative 1, so we're going to close that circle. And if m is greater than negative 1, how do we decide what numbers those are?
Then you would put it that way, showing that it can be anything.
So that means that 0 is greater than negative 1?
Yes.
And then 1 would be greater than negative 1? Yes. And then so like 25 would be greater than negative 1?
Mm-hmm.
Perfect. You want to do another one over here?
Sure.
Okay, so over here, let's write, you can write it with blue. X minus 7 equals, oh, I'm sorry, we're not equaling. We're going to go less than is less than 12. Okay, so how would I do this one?
Then you would...
Because are we multiplying now?
No.
No, what are we doing?
You would add 7 to 12.
And I'm adding 7 because it is the
inverse
of the other one, so we're going to add 7. Are we going to add 7 anywhere else?
Yeah, 2 7 also.
Okay, okay, we have to use inverse operation to cancel.
That would just make x by itself.
Okay, x is less than 19. Okay, so how many values are we talking about here? Infinite amount of values. We're going to show that on our number line. Okay, so what kind of circle are we going to put on 19 this time? Choose this pen.
We're going to do an open circle.
An open circle. So does that mean 19 is included when we open the circle?
No.
Okay, go ahead. So we'll open circle, which does not include 19. And what numbers on the number line are less than 19?
Anything to the left.
Anything to the left. So every number to the left. So 18 is less than 19, and then 0 would be less than 19. And here's the top to that pin. Perfect job. Thank you very much. Back to you in the studio.
All right, thanks for that, April. Great work out there at Actus Junior High. Hey, we do have phone tutors available until 5:30. We've got a very hard worker in studio with us right now, Audrey, so let's put her back to work. All right, young lady, back to the board with you. Here comes your next problem.
Let me move this back up so we can have something to move down. Okay.
24 minus A is equal to 2, open parentheses, 2 plus 4A, close parentheses, plus 2. All right, have at it.
So it looks like you're bringing down the 24 minus A.
And then equals, and then 2 times 2.
That's right. 2 times 2 is 4.
Plus 8. Oh, that does not look like
I
an
can
8.
see that it's an 8. 2 times 4A is?
8.
8.
A.
Good.
And then plus 2.
Okay.
Then 24 minus A.
Bring down the 24 minus A again.
Equals, and then combine like terms. So it'd be 6. Oh, that's
Okay.
6 plus 8A.
Good. Have you done it with variables on both sides? Well, you know how you can take off numbers from both sides?
Yeah.
You can also take variables off both sides. So I could get rid of subtracting A by adding A. And then I would have to add A to that side too. So why don't you just try that and see what happens?
Oh.
Okay.
So then
Go ahead.
just be 24 equals 6 plus.
So 8 A's plus another A. If you have 8 alligators plus an alligator.
Is 9.
9 alligators, yeah, 9 A's. Okay, let me move it down. You did really good with that. So that's a new thing? Great. Okay.
And then
So you're trying to isolate that 9A.
so then it's minus 6.
Great.
And minus 6.
Mm-hmm.
Be 18 equals.
It's okay, the positive doesn't hurt.
A.
That's actually a good habit that you have of not leaving off that sign in case it's negative, right? Okay, so now what do you do?
Divide 9 into 18.
Right.
Which is 2.
Uh-huh.
So A equals 2.
That's correct. Let me show you something. Not everybody does it this way, but some people divide it like this. I need to divide both sides by 9 in order to get rid of that 9. Now it turns into 1. 1 times A is A, and 18 divided by 9 is 2, just like you said.
All right, so you ladies came up with A is equal to 2, and that's what you said. How do you know that it's 2?
Ooh.
Is there a way that you can do that to make sure that you're positive with that answer and it's correct?
Okay, so let's go back up here. Okay. Because this is how we find out if we made a mistake. So have you done that before? So I have 24 minus, and I'm going to change the a to a 2, okay?
Okay.
Equals 2 times 2 plus 4 times 2. What's 4 times 2?
8.
Okay, and then plus 2. Okay, so what's I'm going to go backwards. What's 24 minus 2?
22.
Okay, 22. Okay, and then I have 2 times, what's 2 plus 8?
10.
10. Does it look like it turned out to be true? Yes, because this here is 20. Okay, so 20 plus 2 is 22. So when you put the number back in, you want it all to be true. Okay?
All right, nicely done. Well, clear the board, ladies. I've got one more for you, but this time we're going to throw some negatives in there for you.
Whoa.
All right, so here we go. Negative 6 minus x is equal to negative 3, open parentheses, 4 plus x. Close parentheses and solve for x.
Okay.
Okay.
So you certainly know how to get started on this one, don't you? Okay. So you're going to bring down that.
Yeah.
That's right.
Negative 6. And then negative 12. And negative 3x. Because 3 times x is 3x.
Okay, so now we have that same problem again where we have x's on both sides. Okay, so you can get rid of negative x by adding x to both sides, or you could get rid of negative 3x by adding 3x to both sides. Which one do you want to do?
Add 3x.
Okay, that's a good choice. Okay, because you will have less negatives to work with. Okay, so add 3x to both sides.
So this cancels out.
That's right.
And then, would that be just 3?
Or you bring down the negative 6 first. Okay, and that is a common thing that happens. People think 3x minus x is 3 because you just take off the x. But this actually means like 3 x's and then take away an x. So it's like 3 x-rays minus an x-ray.
So it's 2x?
2 x-rays, yeah, 2x. And it's positive now. Excellent.
So then you add 6.
Very good.
To both sides. 2x equals negative 6.
Good.
Then
So
be x is equal to 3.
almost. Just think about the sign. You have negative 6 divided by 2.
So it's negative 3.
Right, x equals negative 3. So you divided both sides by 2. That gave us x. And then negative 6 divided by 2 is negative 3.
All right, nicely done. Been doing some great work. And we need to make sure that when we're doing math, we are fed properly. We don't want to do math problems on empty stomachs. So what we're going to do is send you to our friends over at Chick-fil-A and just use a meal over there. So congratulations on that. So I've got one more problem for you before we let you take a break for a minute. You ready?
Okay.
All right, so this is going to be a ratio problem. So you can just write down some, so Susie, maybe just write down any information you guys think you're going to need. All right? In a certain room, there are 28 women and 21 men.
Okay.
What is the ratio of men to women? That's the first one. So the ratio of men to women. And the second part is, what is the ratio of women to the total number of people in the room.
Tricky. Okay. Of women to the total?
Of women to the total number.
Okay, so I used M for men, women, and total. Okay? Well, do you want to know what to do? Can you reach over here and do it? I think you could.
For men to women, it's 21 to 28.
Good.
But what do we want to do with that?
Yeah, do you have to simplify it when you're in your class?
No.
Well, when you get to my class, you will. So we'll get ready for 7th and 8th grade here, okay?
Okay.
So if you write it as a fraction, well, I didn't write that very well. Would you know how to simplify that?
Divide them both by 3.
Well, 21 is divisible by 3, but not 28. I think I know what you were getting the 3 from,
7.
though. Yeah. And now what do you have? Almost. I think that, I don't know if your 4 turned into a 9 or what. There, now it looks like a 4. Okay, so that's the simplified ratio. Okay? Now how about women to the total? How could you get the total?
You add women and men.
Very good. Okay, so what's the total then?
49.
Okay, so 49 is the total. Okay, so now you want to do women to the total. Should I give you some more room? Oh, we might have to go the other way. Okay, we're going to do women to the total up here.
Okay. 8 to 49.
Now, we could make it a fraction, or you could think, which number, can you think of a number that goes into 28 and 49? It might be the same one you used in the last problem.
7.
Right, so what's 28 divided by 7?
4.
So like if I did it like this, oh, that's interesting how it changed color on me, huh? What would I get? You can tell me, because I'm taller than you, okay? Here, what's 28 divided by 7?
4.
And what's 49 divided by 7?
7.
Okay, so you can write it as a fraction, or you can write it like this, or you can write it like this. Did you learn all those ways to write it?
Yeah.
Good.
All right, nicely done with the ratios right there. 636-4357 is the phone number. We do have phone tutors available until 5:30. Programming note, we'll also keep reminding you of this today and tomorrow, the final 2 days of live broadcasting for Do the Math this season. We'll be back with more right after this. Today we're at Sunset Middle School, home of the Rockets, and today we're here to
Do the Math! Yay!
Well, this afternoon we're at Sunset Middle School, and I've got 8th grade student Haley with me. How are you?
Good.
You ready?
Yeah.
All right, let's go. We're going to work on calculating the percent of a number. What can you tell me right now about percent? Is there anything you know about percent? What can you tell me? If you take a test, what's the highest percent you can get?
100.
So you want to get 100, right?
Yeah.
So percent is something out of 100, because you always get 100?
Yeah.
You always get 100 on every test?
Oh, no.
Oh, okay. I was going to say, I'm start studying the way you study, because I know I've never gotten 100 out of everything I've done. So a percent is some part out of 100. So the 100 is the whole thing, okay? So we want to find 32% of 29. So how would you go about solving this problem?
Dividing.
You want to divide? What else could you do? Do you know what the word of means?
Yeah.
What? In math, it means a certain thing. Okay, so it means we're going to multiply something. Okay, now we could go 32% written like that, but it's going to be more difficult. So how could we rewrite that to make it easier to multiply? Because if we have a percent, let's say you got a 90% on a test. That would be the same as 9 out of 10 or 90 out of 100, correct?
Yeah.
But we really don't want to deal with fractions. If we can, let's do it with decimals, all right? So how would we rewrite this as a decimal? Do you know how to do that? If we go 0.9. You've seen that before?
Yeah.
Right, okay. And then 90 hundredths, right, would be the same thing, okay? But we just don't need that 0 at the end because we just have 0.9, all right? So if I want 32%, how would I rewrite that as a decimal?
0.32.
Right, so why don't you go ahead and put 0.32 right there. So 0.32 is 32 out of 100, which is what that means, 32 out of 100, okay? So it's going to be 0.32 times what?
100.
Well, we're going to go times the other number we want, right? So go ahead and rewrite that number. So we have 0.32 times 29, all right? So we'll get rid of this so we have more room to work here. So now, when you multiply, if you multiply with a decimal, we don't even have to worry about the decimal right now until we get to the answer. All right, so go ahead and multiply those for me and show me how you're going to multiply that out. All right, now there are some students watching this that aren't really sure on how to multiply yet, so explain to me what you're doing as you're doing it.
So first I will multiply 2 times 9, then I'll multiply 9 times 3.
Okay, so we know that 2 times 9 is 18, but why do you only write an 8?
Because we can't put both numbers right here, so I'll put the 1 over the 3.
Okay, so you're going to carry that 10. Okay, so now what do you want to do?
Multiply 9 times 3.
And what's that?
27.
Mm-hmm. So you said 9 times 3 is 27.
And it would,
well, what are you doing erasing already?
I had to add a 1.
You had to add the 1. Why do you have to add that 1?
Because I can't leave the 1 right there.
You can't leave it by itself, right? You put it up there for a reason, so we're going to use it, right? It's another 10. Okay, so now what does it become?
28.
All right. Now what do we do?
Then we multiply 2 times 2. Well, first we would have to imagine that there's a 0 right here.
Well, you can put a 0. We don't have to imagine it, right?
Oh,
so a placeholder, right? Sometimes kids put an X or different things in there, but a 0 will work as well. All right, so now what?
We'll multiply 2 times 2, which is 4.
Good.
And then 3 times 2, which is 6.
Now, before you keep going, you've done everything perfect so far. So you went 2 times 3 is 6. Do we need to use that 1 again?
No.
Why not?
Because we already used it.
Because it was part of the 18, right?
Yeah.
Okay. I just want to make sure, because some kids will go, well, you used it once, why not use it again? But that's why. All right.
So then we just add it.
All right.
And we just add a decimal right there.
Why do we put the decimal? Make it a little darker there. Why do we put the decimal right there?
Because we had a decimal right there, but since we didn't use it right here, we just had to put it right there.
But why not right there?
Because we only moved it. We only had to move it once.
If we have it here, how many numbers are after the decimal point?
2.
2, right? So in this number, right, you had 9, 2, 8. If there is no decimal in a number, where is it? Just think of 928. Can I write 928 like this?
Yeah.
I can still do that, right? So if there's no decimal present in a number, it just goes at the end, right? So 928 is what you came up with. And there were 2 numbers after the decimal point here. So in order to make it 32, you had to move it 2 places, right? Okay? So what we're going to do is we're going to move this 2 places, right? 1, 2. So we get 9.28, which is the same thing you got, isn't it?
Yeah.
Okay. How would you read that number instead of saying 9.28? Can you think of another way to say that? Because if I have this, how would I say that?
2 out of 10.
2 out of 10, or I could say 2/10, right? How would I say this?
2 out of 100.
2 out of 100, or
2 hundredths.
2 hundredths, right? Because there's 2 places. So this is the tenths, this is the hundredths. So now how could we say this? We could say 9
out of
and
28 hundredths.
There you go, because of the 2 places, right?
Yeah.
So you have the whole number, and then the decimal point is always and. So it's 9 and 28 hundredths. But, so what is 32% of 29? What is our answer?
9 and 28 hundredths.
9 and
28 hundredths.
There you go, 9 and 28 hundredths. Haley, good work. And a big thanks to all of the staff and students out there. Always great to go do a little math in your class at your school. And if you'd like to do the math to visit your school, all you have to do is give us a call. The phone numbers are periodically at the bottom of your screen. Just say, hey, next year when you guys are going out, come on out to our school, check it out, and we'll do some math with you guys. We're going to make Audrey do some more work, but we're going to let her rest for a moment. Right now we're going to go back out to Actus and visit with April.
We're here at Actus in their ACES program after school, and now I'm here with Anna. Anna, what grade are you in?
7th grade.
7th grade. And this is the ACES after school program, right?
Yes.
What do you like about ACES?
I like to cook.
You like to, what's your favorite thing that you've made here at
No
ACES?
baked Oreo.
What's it called?
No baked Oreo.
That sounds delicious. What'd you guys use for the, like, filling?
Vanilla.
Vanilla, and then what'd you use for chocolate?
We just use the Oreo.
The Oreo. Was it yummy? Yes. All right. So today we're going to do a math problem. Let's go with, we're going to solve a 2-step equation, right?
Yes.
Okay, so let's go with 5x minus 9 equals 21. Do you know why this is called a 2-step equation?
No.
It's okay. We'll figure it out in the end. Okay. So, what's a good thing that we can do here? When we have equations, we have to balance our equations. So I'm going to put a balancing line here. Okay? And this line is going to tell me if I complete an operation on the left side of the equal sign, I have to complete the same operation on the right side of the equal sign, right? Yes. Okay, so what's the goal here? What are we trying to do? In 5x minus 9 equals 21, what do we need to find?
We need to figure out what the x represents.
What the x represents, okay? So we want to isolate that x, and in order to do that, what should we do first? It says 5x minus 9, so what should we do?
Make it a positive 9.
So we're going to add 9 with a plus. And to keep my equation balanced, so if I have a plus 9 on the left side of the equal sign, what do I have to write on the right side of the equal sign?
9.
Plus 9. And then draw a line right underneath that. Okay? So what happens with negative 9 plus 9?
Become a 0.
Yes. So let's just cancel that out. And on the left side over here, what do we have left? Like if that's 0, what do we have left there?
The 5x.
Let's go ahead and bring that down under the green line. And then our equal sign again. On the right side, 21 plus 9 is?
30.
30. So I have 5x equals 30. So 5x, what kind of math is going on there? Are we adding, subtracting, multiplying, or dividing? 5 and x.
Dividing.
But with them next to each other, this is multiplication. So what's the opposite of multiplication?
Division.
Division. So I'm going to divide by
5.
5. And on the left side, I have to do on the, keep my equation balanced. On the right side, I'm going to divide by 5. And what's 5 divided by 5?
6. Wait, 5 divided by 5?
Yes.
1.
1. Okay, so then that's going to be a 1, and we don't necessarily have to write that 1. So let's put an x over here. And 30 divided by 5.
6.
6. And so now we found the value of x, right?
Yes.
All right, so count with me. Start with 1. Count.
9.
1, 2. How many steps did you take?
2.
That's why it's a two-step equation, because there's 2 steps. Let's do another one. So we've got 2x plus 3 equals 9. So how would I solve this equation, this two-step equation? So let's draw a line, there we go, for our balancer.
Wait, this is to be a negative 3?
I'm going to subtract 3 because it's the inverse operation, right? And is my equation balanced or imbalanced right now?
Unbalanced.
In balance, how do I balance it? If I have subtracting 3 on the left side, where else do I need to subtract 3? Okay, let me see it. So on the right side as well, we have to subtract 3 on both sides of the equal sign. Let's go ahead and draw a line. And we're subtracting that 3 because we need to isolate x and cancel out anything that's on the same side of the equal sign. So that 3 minus 3 is going to...
0.
Okay, so cancel it out. What do we have left?
2x.
2x. And 2x is going to equal... What's 9 minus 3?
6.
6. Go ahead and write 6. That's step 1 of our two-step equation. Okay? So now I have 2 times x equals 6. What's the opposite operation or the inverse operation here?
Division.
Division. I'm going to divide by
2.
2 on one side of the equal sign?
Both sides.
Both sides of the equal sign. And 2 divided by 2 is?
3. Wait, 2.
2 divided by 2, this side. 1. Okay. So that gives me 1x. So all I have is an x over there. Mission accomplished. And x is going to equal 6 divided by 2?
Will be 3.
3. And that's the value of x. Great job. Back to you in the studio.
All right, thanks for that, April, and thanks to the students out at Actus Junior High. We also had Audrey working on that while she was singing back here in the studio. Now it's time for you to get back to your own work, not doing the other kids' work. So back to the board with you, young lady. Here we go. So 3 over 12. So we're going to multiply fractions. 3 twelfths. So 3 over 12 times 4 over 21. And there are a variety of ways to solve this. So I'd like you to show me 2 ways you can do this problem.
Oh, well, I won't move it yet.
You can do the cross canceling and you divide.
Okay.
So it'd be 3 divided by 21 is 7.
Or you can think how many?
And
3 goes into 21 7 times. Okay.
Yeah. And then 3, 23.
Here, I'll write it up here again. Just go ahead and do it how you want to do it, and then we'll do it another way. Okay?
Okay.
So you can go ahead and cross out. You can cross cancel. Do you remember how to write it? Okay. Well, there's different ways, but 3 goes into 3 once, into 21. I don't know what I'm doing. 7 times. Good.
And then working on 12.
Yeah. Go ahead. Now you know what to do. Okay, I'll help you. 4 goes into 4 once, and 4 goes into 12.
3 times.
Good.
So it equals.
Now do you know what to do? Multiply the numerators.
1 times 1.
And multiply the denominators.
21.
Very good.
So now what about the other way? Let's say she didn't know about cross-canceling or simplifying first. What's another way you could solve that problem?
So if you don't know anything about cross-canceling, you go ahead and multiply the numerators. Good. And then if we multiply the denominators, well, here, let's put it here where you can do it. Okay, better, easier.
And then placeholder.
Well, you're pretty fast.
252.
So write that there. Okay, so I'm going to erase this so you have room now, okay? So whenever you have something like that, you need to simplify. Do you know how to simplify it?
Divide.
Yep. Can you think of a number that goes into 12 and 252? Well, they're both even.
So 2.
You could try that, okay. Okay, and then what would you get?
6 over.
You could do partial quotients. 252 divided by 2. 200 divided by 2 is?
1.
Okay. 1. And then 52 divided by 2. What's 50 divided by 2?
Oh, 52. 25.
All right, so 52 divided by 2 would be one more.
26.
Right, 126. Oh man, we still got a big problem here. You know what? I'm going to just try 6. How could you find out if 126 is divisible by 6?
Well, you can do 12 divided by 6.
Okay.
And then do 12 divided by 6.
Okay, so 12 divided by 6 is 2.
2.
And 6 divided by 6 is?
1.
Good. Did we get the same answer? We sure did. And in fact, you could have divided by 12 over 12 here to make it faster, but it's kind of hard to see that 252 is divisible by 12.
Right. Nicely done, though. She got it the simpler way the first time around.
Yeah.
So I was expecting you to kind of just multiply straight across the first way. But you did both ways and you got it correct. So, hot shot, let's try another one. You ready? Instead of multiplying, now we're going to divide. So 5 over 6.
Let me move this up so I have room to, okay.
Divided by 2 1/6.
Okay. Do you know what the first step is?
No.
Well, when I teach this to my students, I tell them they have to first change mixed and whole to improper. Do you remember? So you have heard that step, huh? Okay, so 5/6 is okay, right?
Mm-hmm.
Do you know how to change 2 1/6 to a?
6 times 2 plus 1.
Right. So that's 13
over
6. Okay. Now, it is possible to do division this way, but you have probably been taught
to flip it.
Yes, and that's called multiplying by the reciprocal. So let's write the new problem. Well, here, we'll bring it down. Okay, so what's the new problem?
6 over 5 divided by 13 over 6.
This one stays the same. Okay, do you remember that? And this one changes to multiplication, and then you change it to the reciprocal.
So 6 over 13.
Right, that's correct. Okay, and since you did so well with that other multiplication problem, I bet that you know what to do here. Do you see?
Oh.
Yep, you saw it.
So this is 1, and this also turns into 1. So then, 5 over 13.
Good. So I'll tell you a secret. It doesn't happen very often, but see how these were the same there? 5 divided by 13 is 5/13. But that doesn't happen hardly ever. So it's not something we teach very often.
All right, well, you know what? You ladies are on a roll. We're going to give you one more problem. I'm going to modify this one off the paper a little bit now.
Okay.
All right, 11 5/7. 11 5/7 plus 8 6/7.
Okay. So how do you like to do these? Some people like to stack it, and some people do like to change them into improper fractions, which is a good thing to do if you have negatives or borrowing, regrouping, but you actually don't need to do it here. Do you know how to do it stacked? Where they're on top of each other? Okay, so let me, okay, go ahead. You do it the way you want to do it.
19.
Mm-hmm.
And then that changes into a mixed number. 13 over 7.
Well, that would be correct if you did 5 plus 8. But you actually have 5 plus 6, yeah. Okay, so are you done?
No.
What do you think you could do?
You have to change that to a fraction.
That's right. You know how to do it?
You divide.
Right, you can divide. I'm so glad that you know how to put the numerator inside. Okay, so how many 7s go into 11?
1.
1. And 1 time, good. And there's 4 parts left over. And what kind of parts are they?
Remainder.
They're 7s, aren't they? So 1 and 4 7s. Okay, so what do you do with this?
You add it to this.
Very good.
So it's 20 and 4 7s.
Excellent.
There you go. Nicely done. Could not get one by you today, Audrey, right there. Hey, you know what? Come on over here again real quick, Audrey, because you said that you are looking forward to junior high. And what is your favorite subject right now?
Math.
You like doing math, right?
Yes.
I mean, you know, you're not only saying that because you're on Do the Math today, are you?
No.
You really like doing math? Well, you're going to do a lot of it next year, and you're going to do all of the things we did today and a whole lot more. All right? You know what? Actually, we're going to go one more time out to Actus and see what they're working on. So we'll go out to Actus with April one more time.
Hello, we're back here at the home of the Americans, and this time I have Lindsay with me. What grade are you in, Lindsay?
8th grade.
8th grade. And what's your favorite subject here at Actus?
English.
English, not math? It's okay, we'll take that. But in math today, we're working on, do you remember what we're working on here?
Unit rate.
We're working on unit rate. So John baked 63 cakes in 7 hours. How many cakes did John bake per hour? What does per hour mean? How many hours is that?
Just 1 hour.
Just 1 hour. Okay, so if you have to mark the text here, what would you do? What's the important information that we need in this scenario? Per hour, 7 hours, 63 cakes. And why did we underline those pieces? Why are they important?
Because we're going to be using them.
Because we're going to be using them. Sometimes numbers are important in a word problem because we need them. So we're going to be using 63 cakes, we're going to be using 7 hours, and we're looking for per hour. So we know that John can bake 63 cakes in 7 hours, but we have to find, what are we finding?
The unit rate.
The unit rate, which is how many cakes in?
An hour.
1 hour. Okay, so how would I do that?
Divide 63 and 7.
So show me what that looks like. How do you know to divide?
Because we're looking for per hour.
Per hour, so it's a unit rate, so we're going to put groups into it, see how many groups of 7 can we get out of 63. So how many times does 7 go into 63? I think I picked the wrong number.
8.
Let's check 8.
That's 56, right?
So did we go 7 into 6 or 7 into 63?
7 into 63.
So your 8, should it be over the 6 or the 63?
63.
Okay, so when I subtracted, I have 7 more left. So since this number is not less than this number, is this number big enough? So what's bigger than 8?
9.
Let's check it over here real quick. What's 7 times 9? I guess you'd have to know 7 times 9. What's 7 times 9?
63.
63. So how many cakes will John bake per hour?
9.
9. So can you write that right there? 9 cakes per hour. Let's make a sentence out of it. Nicely done. Okay, so how about we come over here? And we have another problem. Same type of problem. Is this a unit rate problem? I guess I should put a number here, huh? Okay, so we'll put that number here. So Sarah jogged 14 miles in 4 hours. How many miles will Sarah jog per hour? So what should we do here? Are we looking for a unit rate?
Yes.
How do we know? Because it says, what's the indicator?
Per hour.
Per hour. We're going to underline that. And what other information do we need from this word problem?
The numbers.
Yes, 14 miles and 4 hours. So we're going to do the same thing that we did before?
Yes.
Yes. So jogging 14 miles in 4 hours, how many per hour? So we'll divide what by what?
14 and 4.
14 by 4. So 14 divided by 4. So that number is less. What if you put a decimal after 14 and a 0 and bring down the 0? Will 4 go into that number?
Yes.
How many times?
5.
5. We're going to put that. And we're going to bring that decimal straight up. And what do we know about 3.5? What does that represent?
Miles she jogged in an hour.
Who jogged?
Sarah.
Okay, so how would we answer that? How many miles did Sarah jog per hour? You can just say it out loud.
Oh, okay. Sarah jogged 3.5 miles per hour.
Awesome. Thank you so much. Back to you guys in the studio.
All right, thanks for that, April, and thank you to all of the students out there at Actus Junior High. As a matter of fact, we have all of their names in a drawing because every day what we like to do is take all of the students that have done math problems, put their name in a drawing for an athletic event of their choice, courtesy of our friends at CSUB and the CSUB Athletics Department. So, Audrey, if you would reach in there and pull out one of these names and we'll find out who's going to an athletic event at CSUB.
Lindsay.
Lindsay, there you go, an 8th grade student. I do believe she was the young lady just working on that problem right there. So congratulations to Lindsay. Hope you have fun out there. Any athletic event you'd like to go to out at CSUB, so congratulations on that. Hey, we do have phone tutors available until 5:30. We have our newest ambassador, Audrey. You know what that means? That means you have to tell people about Do the Math. Can you do that for us? All right, you know what? We even have a uniform for you in doing that, all right? All right. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.